Welcome. In this video I'm going to show you how to obtain effect sizes for a post hoc test of a goodness of fit test using Python. I'm using Jupyter Lab as a standalone with a Python 3 kernel. I think it's 3.8.13. Now, I've separate videos on each of these because they're actually the effect sizes from the one sample binomial test and variations that you can use. So, for example, Cohen's G or Cohen's H2 or the alternative ratio, or sometimes referred to as relative risk. I've separate videos and notebooks on how to calculate each of these separately. Here the focus will be on how to actually implement them if you're doing a post hoc analysis with pairwise test. To show an example, I use pandas to load a GSS 2012A data file, which is General Social Survey from 2012, and A means that it's slightly adjusted. The field I'm interested in is the marital status, so I'm going to use mar1, which is that field. I can have a quick look by using the value counts and notice then that 181 people, for example, selected widowed. Now, I'll probably need the count separately, so I'll label this as my counts, and the labels are actually also useful, so I'll store those as my labels with an index to list option. And then if I print my labels, you nicely see that I have those category names separately. Then I need all possible combinations of these two, so married and never married, married and divorced, etc. And for that I can use from itertools the combinations function. And if I run that, I can actually have the counts separate and the category names, the values if you will. And if I run this, you will see that each combination is now actually there. Then I can loop over all of them. Determine that specific effect size over all these possible combinations and calculate the appropriate effect size for each combination. So I need NumPy and math, and then I can do this whole thing where I basically set up my effect sizes starting as empty arrays, then loop over each possible pair, calculate the proportion in each pair, because there are only two categories, so there's the proportion of the first category and the proportion of the second. Then calculate Cohen's G, Cohen's H2 and the alternative ratio, and then bring this all back into one nice pandas data frame so we can actually have a look at the results. So here I have all those possible pairwise comparisons. The sample sizes, so the sample size of each category basically, the Cohen's G result, the Cohen's H2 result, the alternative ratio based on the first category, and the alternative based on the second category. If you're interested, I actually also made one long function that can do everything, including the pairwise binomial test. So that's shown over here, and if I run that, it actually gives me the all the information I'm interested in from a pairwise test, or pairwise binomial test in this case. Okay, I'll leave a link to my website where you can download this notebook if you want to follow it along, and I hope this was helpful, and thank you for watching.